Hello, hello. Welcome to this tutorial. This is the fourth tutorial where we will be discussing about InterVlan routing. Let us understand to the Cisco packet tracer example. InterVlan routing is as follows. We can see is as follows. The network consists of multi-layer switches, three access layer switches, the PCs or the end devices, and server. The link between the multi-layers before we walk into the link, we will first see what are the configurations. We see that all the layer 3 switches here, that is switch 1, switch 2 and switch 3, all the layer 3 switch with IP have been assigned an IP address with inter-VLAN routing, and they are as follows. VLAN 1 has been assigned IP of 10.1.1.254/24. VLAN 10 has been assigned the IP of 10.1.10.254. Similarly, VLAN 20, 30 and 100 are 10.1.20.254, 10.1.30.254 and 10.1.100.254/24 respectively. After that, the switches have been assigned. Switches will only have management IP addresses in VLAN 1, and those switches have been assigned the IP addresses as 10.1.1.1, 10.1.1.2 and 10.1.1.3 respectively. And finally, all the access ports or the PCs or the end devices have been assigned the IP address as 10.1.10.10, which is connected to switch 1, a 10.1.20.20, which is connected to switch 2, and 10.1.30.30, which is connected to the switch 3. Now the link between the server and the multi-layer core switch is of type access mode. The link also similarly, the mode between the access layer switch and the end device or the PC is also access mode type, but the link between the multi-layer switch and the access layer switch is of type trunk, or is in trunk mode, because when we have to perform inter-VLAN routing. For instance, when PC1 wants to send a packet from VLAN 1 to, let's say, VLAN 2, or that is PC2, then the PC1 has no idea or no information about the VLANs. So it forwards the package to the switch which it is attached to. The switch, knowing the switch connected to the multi-layer switch with the help of trunk mode, will encapsulate the packet and add a tag bit which will contain information about the VLAN. And when the packet reaches the multi-layer switch, identifying which VLAN the packet is designated to, it will forward the packet and it will go to the respective end device. So therefore, the main use of trunk mode is to encapsulate the packet and identify the designated VLAN, and hence transfer the packet to the destination. Now we will see how all the configurations have taken place with the help of following commands. I have already configured this network. I will walk you with the input and the output. We will first see the configuration of multi-layer switch. Under multi-layer switch, we will first type under configuration switch. We will go to we will type under the CLI, that is the command line interface, the following commands. conft, that is, we'll enter the configuration mode. First we'll type enable, and then which will basically allow us to log in as with privilege mode. Then configuration T, which will basically allow us to configure the switch according to our requirements. Then VLAN, and then we type VLAN 1, VLAN 10, VLAN 20, VLAN 40, and VLAN 100, which will basically help us start with the VLANs. After that, we will start configuring the interfaces which the switches is attached with. We have in all total 4 interfaces. One interface which is of access mode type with the server. Let us configure it first. We can see from the following command. First, we will type configure T to configure the switch. Then the name of the interface gig or G 1.1/0/20. Then you can skip this do show IP in brief. You can skip this for right now. And then, since the interface between the server and the multi-layer switch is of type access mode, so we write switch port mode access. It enables the access mode for that particular interface. And then finally, we also assign VLAN 100 to that interface. So switch port access VLAN 100 end, and then end. So we configured the VLAN 100 as well as the link between the switch and the server, and hence we come out end. Next we configure the trunk mode interface between the multi-layer core switch and the remaining three access layer switches. The command for all the three is same, only the interface name changes, and I'll just walk through you through one code, and the remaining is the same. For let's say we'll do it for configuration. We'll do it for switch 1. Configuring the interface between the multi-layer switch and the access switch 1. We type config t, then we write the interface name, that is interface name here it is gig 1/0/1, which can be seen from here, and then since it is of type trunk, we write switch port trunk encapsulation dot 1q. This will enable encapsulation protocol, that is 1q protocol, and then finally we write switch port mode trunk, and hence the configuration of the interface between switch 1 and the multi-layer core switch of type trunk has been successfully done. Next, similarly you do it for interface G101/0/2, and similarly for interface gigabit internet Ethernet 1/0/3. After configuring the interfaces, we also need to configure the VLANs as follows. We write configure t int VLAN 1 no shut, which will basically up the link from the downstate, and we assign them the IP address as we can see it from here as IP address 10.1.1.254, and the subnet mask of 255.255.255.0. Similarly, we do it for VLAN 10, 20, 30, and 100 with the respective IP address which has been previously been written. The next step is to end and come out of the configuration. To see the output, I can show you the multi-layer switch, and the following we can see all the configuration that have been set by the following command: show running config, and we'll see all the commands now one by one. So the first interface was gigabit 1/0/20, which was of we can see gigabit Ethernet 1/0/1, which is connected to the access layer switch, and it is of type trunk. We can see that the configuration was successful. Similarly with the other switch 2, similarly with the interface of switch 3, and finally with the server, it is of type access, and we have successfully configured it properly. Now we can also see that all the VLANs, that is VLAN 1, VLAN 10, VLAN 20, and VLAN 30, and VLAN 100 have properly been given IP addresses. We can see it from the following, and yeah, so we properly configured the multi-layer core switch. Now we need to configure the switch ports or the access layer switches. We can see for each switch we need to configure two interfaces. One is the trunk interface, which is connected to the multi-layer core switch, and another interface which is of type access, which is in access mode, that is connected to the end device. Let us walk in through the configuration code for the access layer switch. For the access layer switch, we will type. For the access layer, we go to the switch, and under the CLI, under the command line interface for switch 1, we type the following: configure T interface. We are configuring the interface between the switch and the multi-layer, which is a multi-layer core switch, which is of type trunk. So switch configure T interface G gigabit Ethernet 0/1, and then switch port mode trunk. This command will basically enable it as our interface in trunk mode, and then we finally type end and come out of the interface configuration. Now we do similarly for interface F01, which is for fast Ethernet, which is connected with the end device, which is as follows: configure T interface configure T in fast Ethernet 0/1 switch port mode access switch port access VLAN 10. We are basically adding that, adding that access link to VLAN, assigning them to VLAN, and assigning the interface to VLAN, and then exit. After assigning both the interfaces, or configuring both the interfaces of access layer switch, we finally write the last two commands, that is VTP domain CCNA. This basically enables InterVlan routing, and finally we also write VTP mode client, which enables the which enables the access layer switch to tell, or basically it can learn from the multi-layer switches which it is attached to. Similar, and hence now the configuration for switch 1 is over. Similarly, we need to configure it for switch 2 and switch 3. Now since we have configured it successfully, now we will try to ping PC1, we will try to ping PC3 from or PC2 from PC1, and let's do it. The IP address for PC2 is 10.1.20.20. Let us ping it, and I've done it from you. We can see it here now. You can see I've pinged 10.1.10.1.20.20, that is PC2 from PC1, and we can see the first request was timeout, and that is right. That's perfectly fine, and the remaining three was successful, and hence we can see our configuration was perfect, and we have successfully implemented InterVlan routing. Thank you.